Hello everyone, let's continue building a dungeon crawler. Today I want to improve the initializer for the world. So I want to make it easier to create worlds. For instance, we have one here that takes in maps and then all these character arrays and player start position, and we manually add an enemy to it. And what I would like to do is I would like to have more of an API that takes a set of strings that represent a map. So for instance, if we take this map here, I would like to have something like the world is a make world that takes a string of 6 of these. And then can take another floor here. And also I would want to be able to specify a start position, for instance here, and specify an enemy, I don't know, for instance here, something like this. I'm actually going to copy paste this because seems reasonable. Let's create a new test that's about creating worlds. To create a map with a single floor based on a multi-line string. And then let's see if we can assert a couple of things. So we should expect that the world oh, maybe we should create this function first, add it to the world. For now, this will take an array of strings and return a world. So this should now compile, so we can use autocomplete to say that the position in this case should be coordinate 1, 1. Also, we should expect that at this position to be 4. And also similar on this one, although it has an enemy, it would be nice to see if that still has a floor underneath. Let's see. Let's expect that at 1 by 1, 2, 3, 4, we have a stairs down. And let's expect this one, so that's 1, 2, 3. We want to be a wall. What else can we expect? The world, can we get the size? Oh, we can get a minimum x, that should be 0. A min y should also be 0. And the max x and the max y should be 5 and 1, 2, 1, 2, 3, 4, 5. And we should have enemies on current floor. Count. There should be 1 enemy. And the enemy should be at position 3 by 3. Okay, so something like this. So this should give us an idea about what we want to get out of this world. Okay, so we crash because we're trying to access a floor that doesn't exist. So let's start implementing this functionality. So the first thing we can do is get some floors out of this one. So for a floor string in floors, well, let's just say we have a floor string, and then we create a floor. We call the map in this case. And the map takes a character array. So we should convert this floor string into a character array. So what we could do is for y in 0 until we take our floor string and we split it into lines. And then we take let's see, I think we can, this can be done easier. So let's see if we can do this in a slightly more elegant way. So let's take our floor string and start by splitting it into lines and map these lines into strings. So now character should be an array of strings. And now we can, and we should be able to split this one again into characters. And this should lead us with a character array. Okay, so it's an array of characters now. So we still need, we are losing I guess we need to split it again. Okay, so we now should have at least some floors. What is this type here? It's annoying that the autocomplete isn't really working here. Let's do it in step. So we have our lines. Then we should eventually get characters by taking our lines and splitting them into characters. And our characters are not, this one doesn't like. Let me see, how did I do this? How do I usually do this? Okay, now I have an array of arrays that's getting somewhere. And maybe if I map this one into a string, into a character, I have an array of characters. We first convert it into strings. Okay, let's see what characters. Now I have an array of characters. That's nice. Now I can enter, create a map out of these characters. And I probably need to do, what else do I need to put in? Starting up, I need to put in this one. Let's see if this at least helps pass a part of the test. Okay, so our starting position doesn't work, although we do have our some floors and some walls. This, by the way, is a stairs up. So I'll explain something. We don't have any enemies yet. That makes sense. But the floor itself is the right thing. So I'm sorry that this conversion of a string to an array of characters was so messy. It took some time. Let me try and explain what is happening. So first we convert the string into separate lines, and we split them at the end of line character. However, that returns a subsequence, and that's not exactly a string. So what we need to do is we then convert them into proper strings. So then we have an array of strings. Then what we want to do is for every line, take the line and convert it to an array of all its characters. And that's what this one does. Basically, what is happening is we get a string element in here, and we convert that one into a character. We need to do that in two steps. First, we need to take the string element, which is in a way a character, but with a slightly different name. We convert it into a string, and then we convert the string back again into a character, and then we have our array of characters. I even think maybe there was a trick in doing it like this. Let's see if this is acceptable. Okay, by giving it still the same ones are failing. By giving it a hint about the return type, it now knows that the string element should be a character. And then we can take our maps initializer that takes an array of characters to create at least the floors. So this is for a single floor. And also, we can even, we'll improve this in a bit. Now we need to look at the starting position. So we have our characters. Let's try and find a starting position. So by default, the starting position is a coordinate 0. But what we can do is we can go from we can go for each character, and if the coordinates or the tile at the coordinates we even don't need this one here. If this is an S, then we set the starting position to X and Y. And now we can pass in the starting position. This one we don't need. Start position, starting position. And let's see if we have some more of the test that's now passing. Let's see. So we now also have the start position that's working correctly. So now we need to look at the enemies. We can do the same trick again. So let's say we have some enemy. What letter did we use for those? Let's go back. A small e. Then we say enemies, append a new enemy at position X and Y. Can we pass in the enemies? No, but probably what we can do is take our world, return the world, and for enemy in enemies. We'll call this, then we can also do this as a coordinate. Then we just add these coordinates. And then we create new enemies here. Let's see if this now passes the test. Okay, so our test succeeded. Let's quickly commit. We have a new test. And the test was called create a world map with a single floor. Okay. Let's go one step further and create a second floor, let's create a test that also checks for a second floor. Create a world. Oh, with 2 floors. And this is slightly more complicated because we don't have a direct way of accessing all the floors in the world. But what we can do is we can create a very simple map that where the first floor is only stairs up, and the second floor is slightly of a different size, something like this, because then we can say world. Let's see, what was the default direction again for north? So then to go there, you should go right, I think. And then we can expect that the world current floor dot max x is 2, because we now have a bigger, well, it should be on the second floor that has a bigger map. And the max y should be 1. So let's see if this, how far we get. So we're trying to access a floor that doesn't exist. So we should make sure that we at least create it. What we can do is wrap this entire thing in a for block. The same here. Oh, and then we need to extract these outside of our loop. This isn't completely correct, but we'll find out once we get a few more tests. But first, let's get this running. Then we need to make sure that we convert these into a map. So we have our floors here. I think we should rename these into floor strings. And then we should say we have floors. So it's an array of maps. And we can append a new map based on our characters array, and then pass in the floors here. Let's see if this at least now passes the test. Okay, so a test passes. So we can define the world in a slightly more easier to parse way. But there are still a few problems. So first off, we can override the starting position in each floor. So if I would add an S here, then the starting position would also be overwritten for the first floor, even though that's the starting floor. So I don't think that's a very elegant way. And also, if I add an enemy here, we suddenly have 2 enemies in also the first floor because enemies are not floor dependent yet. So that's something to improve at a later time. For now, what I would like to do is at least make sure that I can. Let's improve this code a bit. So in the end, this one returns a floor, possibly updates the starting position and finds possible enemy positions. Let's take the conversion to a character array first and extract it into a function, which doesn't work. But okay, we can create a nested function. It's actually more of a matrix, I guess, because it's two-dimensional. And now we have this character matrix. So we could say that we have our characters or a floor string. Now the second part still compile. And then we have things that create find interesting things like the starting position and any positions. So we could. How do I want to do that? So I think I'll create a single function that bring and give and returns both. So we have a find a starting position, starting and enemy positions function that takes a character matrix and returns the starting position and enemy positions. And then we take all this stuff. This is now called the character matrix. And we return our starting position and enemies. So our starting position is the starting position we get from the starting enemy positions. But if it's nil, we take the one we already have. And for the enemies, we append the contents of starting and enemy positions for the enemies. Okay. So this one also works. we can even collapse these two by saying switch on the character matrix y in case this is enemy. In case it's a starting position, we can set the starting position, and then we can have a single loop. Also, we need a default case, and the default case will be to do nothing. So let's see. This still passes. And I think, yeah, we should. This should be enough for now. Let's see if we can use this one and this new function when creating our world. So instead of this, we can do a make world. I think we already created the correct string. And then we have the second one. That's also our target. And I think we're creating an enemy somewhere at 1, 3. 1, 3. So that's here. And we also create a starting position. Oh, that's already there. That's that one. So we should now be able to get rid of this. And we should be able to get rid of this. Let's see if our game still runs as expected. So our enemy is still here. And our target is still here. And we can still win. So it looks like this is still, we can now use this new initializer. And the advantage is, especially larger maps are a lot easier to create this way than previously when you had to put every single one of them in within parentheses or within quotation marks. So that's enough for now. Thanks for watching and have a great day.